So our first question here, we want to find out, we have 4 resistors which all have the same resistance, and want to find out which configuration is going to give us the lowest total resistance. Okay, so if you have everything in series, so if you had all of your resistors in series, okay, so there you have 4 resistors, 1, 2, 3, 4, they're all in series. That would give you the highest resistance because it has to go through this one, it has to go through this one, it has to go through this one, it has to go through this one. So the total resistance, so these are all in series, and so the total resistance would be R1 plus R2 plus R3 plus R4. So it would just be 4 times the resistance of one resistor. Okay, so that's what you would. So that's what you don't want, because that's making your resistance the highest. So it wouldn't be C because that's all in series. So you'd want the opposite of that, which means that you want all of your resistors to be in parallel. So that's going to be option A. So in option A, you have all of your resistors in parallel. So if you start off here, you can go so that's resistor 1. So option A, if you draw it another way, it's like this. Okay, so it's going from, if you're going from A to B, we have 4 paths for the charge to go through. So it can go through the top one, or it can go through this one, or it can go through this one, or it can go through this one. So that means that the total resistance, remember what we do if they're all the same value and they are in parallel, we're just going to divide it by the number of resistors there are. So this will be 1/4. So the total resistance will be equal to 1/4 of the resistance of one resistor. Okay, so option A is your answer here. Now, question number 2, we have a circuit. So we have a battery, which is 52 volts. Oops, okay. So I've just drawn it like this, so you can see that which ones are in parallel and which ones are in series. So this one, these two are 10 ohms, and these 3 are 18 ohms. Okay, so a charge is going to start off here, and it's going to go to the top. It's going to go through this resistor. So once it gets to this point here, it can either choose to go through this one and go all the way back, or it could go straight through the middle one and all the way back, or it could go through the resistor on the right and go all the way back. Okay, so these three are in parallel. So the effective resistance of these three is going to be 1/3 of 18. So 18 divided by 3. So the resistance here will be equal to 6 ohms. Okay, so that's like having a 10 ohm resistor here and a 6 ohm resistor here and a 10 ohm resistor here. So in this question we want to find out how much current is flowing through the resistor number 3. So that's this one here. How much current is going through the resistor on the left? In order to figure this out, we can't just calculate how much is going through here, because that's going to be a portion. That's just going to be a portion of the total, right? Because it hasn't got all of the current going through it. So first what we need to do is we need to find out the total current. So I total, the total current will be equal to the total voltage divided by the total resistance. And so the total voltage here is 52 volts. So 52 divided by our total resistance. So we can, remember we've simplified this one, so these three are the equivalent of just one 6 ohm resistor, and since they're all in parallel we can just add them up normally. So 10 plus 6 plus 10, that's going to be 26. So your total resistance of the circuit is 26 ohms, and that means that your so I'll just write it here. Sorry, it's a bit messy. So the total current going around the circuit is 2 amps. Okay? Now, this 2 amps is going to travel around here, and then some of it's going to go down this way, some of it's going to go through here, and some of it's going to go through here. And because all three of these resistors are the same, they're going to have an equal amount of current running through each one, right? So then the amount of current going through here is just going to be 1/3 of 2 amps. So the current running through resistor 3, or we can say I3, is equal to 2 divided by 3, which is going to be 0.67. Okay, so this is also a relatively common question, and what you need to do, so the steps you need to follow is to find the total current and then determine how much of the total is going to go through that resistor, and that's how you're going to do it. Okay. And then, so then we want to find out how much energy is being delivered by the battery in 23 minutes, and that's in joules. So we have the time. So remember that if you have an electrical circuit, you can calculate the power. So power is the amount of energy being used per second. So power is energy over time, and this time in this question we want energy. So energy is equal to power multiplied by time. So we have the time, so time will be 23 minutes. So 23 times 60, which will be 1,380 seconds. And we need to figure out what the power is going to be. So the simplest one to use here will be VI, P is equal to VI. But you can use any one of the 3 power equations that I showed you before. So we had power is equal to V squared over R, or I squared times R. And we have all that information, so you could choose to use whichever one you wanted. But the simplest one is just going to be this one. So 52, which is our voltage, times our current. And remember, here we have to use the total current because we want the amount of energy being supplied by the battery, which is supplying the total current. Okay, so that's going to be 2 amps. So that's 104 watts. Energy is equal to power multiplied by time. So power is 104. Time is 1380. So that's going to be 143,000 joules. So that's going to be 1.4 times 10 to the power of 5 joules, or option D. Number 4, we have a circuit. So when you look at this one, it seems quite tricky. So we want to find out how much current is going through the 4 ohm resistor. So I'm going to draw the circuit like it is here. Okay, so all right. So I've just drawn it like this, which is exactly the same setup, but it's just drawn a bit so that you can kind of see what's going on. So this one's 2 ohms. This one is 2 ohms. This one is 4 ohms. And we have 1, 2, and 1. So 1 ohm, 2 ohms, and 1 ohms again. So if your current, you're going to start off here at the battery, and you're going to go through here. And then now you can split into 2 pathways. So you can either choose to go down this way. And if you go through this pathway on the left, you're going to encounter 4 ohms of resistance before you get to the other side, right? And then you're going to come all the way back. Now, if you go through the pathway on the right, you're going to encounter 1 ohm of resistance, and then 2 ohms of resistance, and then 1 ohm of resistance again. So in total, so these 3 are in series. So the total resistance through this pathway on the right is going to be 4 ohms, right? So yeah, so this is the same thing as having 1 resistor on the right that's 4 ohms. So basically, you can simplify this problem and just draw it like this. So you can say that there's 1 resistor on the right as well, which is also 4 ohms, okay? And now you can say that because there's 2 in parallel, which are the same value, the effective resistance of this parallel circuit is just going to be 2 ohms, so 4 divided by 2. Okay, so then our total resistance of the circuit, our total is going to be 2 plus 2 plus 2, which is 6 ohms. And so we want to find out the amount of current going through this resistor here. Okay, so we need to find out the total current that's coming out of the battery. So the total current, I total, is equal to the total voltage divided by the total resistance. So that's 6 divided by 6, which is just 1 amp. Okay, so there's 1 amp of current coming out of the battery and going through this circuit. Now once it gets to this point here, some is going to go through the left side and some is going to go through the right side. Okay, and because both of them are the same resistance, both pathways have the same resistance, there's going to be half going through this side and half going through this side. So that's the amount going through here will just be half of 1 amp, which is 0.5. Okay. Is there any questions about that? Yep. Yeah, so that's the next question. So in our next question, we have an example where the 2 resistors in parallel are not the same. Okay, so this is going to be quite relatively simple. Okay, and our next one, we have 2 resistors in parallel that are not the same. Yeah, just divided by the number that are in parallel. So if there's 2 in parallel, you divide it by 2. If there's 3 in parallel, you divide it by 3. Okay. So number 5. Oh yeah, so the answer for the number 4 will be 0.5. Okay. Number 5, we have this circuit here. So we have a 5 ohm resistor, seven ohms, okay, so now so this one's 7 ohms, this one's 3 ohms, this one's 12 ohms, and this one is 4 ohms. Okay, so now the 2 that are in parallel is these 2 here. So now we have 2 resistors in parallel that are not the same value. So we're going to have to calculate the effective resistance of the 2 resistors in parallel. So that's going to be 1 over R1 plus 1 over R2 equals 1 over R total. But I like to do it like this, so we'll just do 12 to the power of negative 1 plus 4 to the power of negative 1, and all of that in brackets to the power of negative 1. So you can do that all in one step, which is a lot less time consuming. And that will give you 3 ohms. Okay, so these 2 circuits, these 2 resistors have the effective resistance of 3 ohms. So now we want to know how much current is going through this resistor here. And in order to do that, we need to find out the total amount of current that's coming out of the battery. Okay, so remember I total is equal to V total over R total. So our total voltage is 24, and our total resistance is going to be 5 plus 7, which is 12, plus 3, which is 15, plus 3, which is 18. So our total resistance is 18. And so that's going to be 1.33 amps of current that's coming out of the battery. So 1.33 amps, and that's going through these resistors, and now it's going to get to this junction here. Now some of it's going to go through this way, and some of it's going to go through this way, right? Now, how much more current? So first of all, which one will have more current going through it? The top or bottom? Bottom, yep. So the bottom resistor has less resistance, so more charge is going to go through the bottom resistor. Okay? So how much more current will it have going through? So the resistance is 3 times less, so there'll be 3 times more current going through the bottom one compared to the top one. Okay. Yeah, so 3 times more current going through the bottom one compared to the top one. So for every 3 parts, so you can say there's 3 parts going through the bottom. There'll be 1 part going through this resistor. Okay? So the total number of parts is 4. So you need to divide 1.33 by 4. So that's 1 part. And so that will give you 0.3333. And then since there's 3 parts going through it, you're going to multiply it by 3. And that will give you 1 amp. Okay, so that means that 1 amp is going through here, and 0.33 amps is going through the top one. Okay, so 1 plus 0.33 is 1.33, which is our total current. Okay. Do you guys get that? Any questions? Yep.
I did it a different way and then still got what I did was I just went 3 ohms divided by 4.
Yep.
And then times it by the number that gave me. So it gave me 0.75 and then I went 1.33 times 0.75. Is that rubbish or? Still got the same answer here.
Yeah, so I think that's fine. Yeah, from what I hear, I think if I understand what you're saying properly, I think that's fine. Yeah, but yeah, of course, that's going to be fine as well, as long as you get the correct answer. Okay, there's always going to be different ways to do it. The most common mistake I see is people say there's 3 times more current, so I'm going to divide it by 3. But that's not right, because you still have to account for a current that's going to go through here. Okay, so you have to, if there's 3 times more, you have to divide it by 4. Okay, and so there'll be 3/4 going through here and 1/4 going through here. All right. Oh yeah, and then we want to find out how much energy is supplied by the battery in 1 hour. So energy is equal to power multiplied by time. Our time is equal to 3,600 seconds, so that's 1 hour. And we need to calculate what our power is going to be. So again, we're going to use VI. So power is equal to voltage times current, and we need to use the total current. So voltage was 24. Voltage was 24, and our total current was 1.333, and that will give you 32 watts. So then energy is equal to power, 32, times our time, which is 3,600. And that will give you 115,000. So 115,200 joules. So that's just going to round up to 1.2. So 120,000. 1.2 times 10 to the 5 joules. Okay, so option E. All right, so we'll move on to capacitors again. We have a circuit with a resistor and a capacitor, and the capacitor is initially uncharged. The switch is closed, which means that the charge can start to flow. What's the time taken for the current in the circuit to drop to 14% of its maximum value? So 14%, initially the current will be 100%. After one time constant, so this is after one time constant, it's going to become 37%. Okay, and then after two time constants, it's going to become 37% of 37%, which is 14%. Okay, and then after this, after a third time constant, it will become 5%. Okay, so here we want to find out how long it takes to become 14%. So we need to find out what two time constants is going to be. So first of all, we're going to find out what one time constant is. Our time constant is equal to resistance times capacitance. So resistance is 1,000, 1 kilo ohms. So times 10 microfarads. So 10 times 10 to the negative 6, which will be 1 times 10 to the negative 2 seconds. So that's, or you could say that's 0.01 seconds. So that's one time constant. What we need is two time constants. So we're going to multiply that by 2. So that would be 2 times 10 to the negative 2 seconds, which is your answer. Okay? So it would take 0.02 seconds to reach 14%. And then again, you've got, once the capacitor is fully charged, how much energy is stored in it. So that's U is equal to half CV squared. So our capacitance is 10 times 10 to the negative 6. And our voltage is 10 volts, so 10 squared. And that will just be 5 times 10 to the negative 4 joules. Okay. Next, number 9, we have an electronic flash gun which uses a capacitor to store electrical energy, and it's discharged through a xenon flash tube. The voltage across the capacitor is 200 volts. The capacitance is 37 microfarads, and the capacitor is in parallel with the flash tube. And the flash tube has a resistance of 1,000 ohms. So we want to find out what the time is for the initial current to decay to 1 over E squared of its original value. So what's going to trip a lot of people up is that 1 over E squared, right? So I talked about this briefly before. So I said that 1 over E is the same thing as e to the power of negative 1. And if you do that in your calculator, you'll get 0.37, which is 37%. So that's just going to be one time constant. Now if you have 1 over E squared, that's the same thing as e to the power of negative 2. And if you do that in your calculator, you'll get 0.001 So you'll get 0.135, but we'll just round that to 0.14, okay, which is 14%. So basically, this is exactly the same as question number 7. Okay, so it's asking us how long would it take for the initial current to become 14%. Okay. So what we need to do is we just need to find 2 time constants. So we're going to find what one time constant is first. So one time constant is equal to RC. So that's resistance, which is 37 microfarads. So 37 times 10 to the negative 6 times the capacitance. Oh, sorry, that's capacitance, and resistance is 1000. So I've just done it the other way here. So that's C and that's R. And that will be, so one time constant is 3.7 times 10 to the negative 2 seconds. Okay, and since we want 2 time constants, you're going to just multiply that by 2, which is 7.4 times 10 to the negative 2 seconds. Okay, so that's about as hard as it gets. They literally ask this exact same question like 4 or 5 times in the last 10 years, and it was in last year's as well. Okay. Number 10, you've been asked to design a simple defibrillator. It's got a 90 microfarad capacitor. You need 200 joules of energy, and there's a 100 ohm resistance. So here you want to find out what the potential difference is. So potential difference is the voltage. Okay, so again, this is going to be, whenever you have electrical energy, you're going to use the symbol U. So you have U is equal to half CV squared. And this time we want to find out what the voltage is. So we need to rearrange this for voltage. So V is equal to the square root of 2 times U, our electrical energy, divided by the capacitance. So that's going to be 2 times 200 divided by our capacitance, which is 90 microfarads. So 90 times 10 to the negative 6. And that will give you 2,108 volts. So that just rounds to option D, 2,100. And then the follow-up question from that question stem. When the defibrillator is discharged through the 100 ohm test load, how long will it take for the peak current to decay to 1 over E squared of its initial value? So that's just 14%. 14% is 2 time constants. So we're going to find out what one time constant is. R is equal to, time constant, one time constant is equal to RC. So resistance was 100. Our capacitance was 90 microfarads, so 90 times 10 to the negative 6. And that's just going to be 9 times 10 to the negative 3 seconds. So that's one time constant. You want to multiply that by 2. And that will give you 1.8 times 10 to the negative 2 seconds. So that's how long it will take for the current to decay to 14%, which is 1 over E squared. So I just went over that in the last question, number 9. Okay. The last question, number 12. Now this is a bit of a concept question, so it is a bit harder. We have a circuit that's assembled and then left overnight. So you can assume that it's been there for quite a few hours, so probably like 5 or 6 hours at least. So you'd want to check. You can assume that the capacitor is going to be fully charged by this time, but you could check whether it would be by calculating the time constant. Okay, so the time constant here would be RC, which is our resistance is 1000, and our capacitance is 100 nanofarads, so 100 times 10 to the negative 9. And so that will be 100 micro, so 100 times 10 to the negative 6 seconds, so 100 microseconds, or in other words, that's 0.01 milliseconds, okay? And usually after about 5 or 6 time constants, it's going to become fully charged, okay? So that confirms that the capacitor will be fully charged in the morning. Okay, so we have this is our battery, so this is our positive side, and it's going through our resistor, which is 1000 ohms, and here's our capacitor. Okay, so we said that this capacitor is now fully charged. If it's fully charged, it means that there's just as many positive charge. So this one was, the battery was 3 volts. It means that the potential difference across this capacitor is going to be equal to the potential difference of the battery, okay, because the capacitor is fully charged. So the voltage of the capacitor is also going to be 3 volts, okay. So that's going to be the voltage of the capacitor. So VC is equal to 3 volts. So it's going to be either option A or B, right? Now, the voltage across the resistor, so what that means is the potential difference on either side of this resistor. Now, on this side, it's 3 volts, and on the left side, it's 3 volts. So is there any, what's the potential difference across that resistor? It's 0, right? So VR is going to be 0 volts. So, well, now you can kind of, it's going to be option A, but now we'll go through the current. So remember that it's voltage that provides the driving force for current to move. So if you had what that means is that this side is just as positive as this side, so there's no driving force for any current to move. So the current I across the resistor is also going to be 0. So that's IR will be equal to 0 amps. Okay. So that's the end of it there. If anyone has any questions, feel free to come and ask me afterwards, because we finished a bit early. I'll stick around for about 20 minutes or so. All right. Thank you. Hey.
please explain this one again?